What is up, mathletes? So today what we're going to look at is this idea of U substitution. Not you, but me. All right, so the key component here is that first critical step. You're going to choose something in this function that you're going to say U equals this, but this is a thought process. Whatever it is that you're choosing to let U equal, when you take the derivative of that derivative is going to be somewhere hidden in that original function, all right? And I'll explain that as I'm doing this problem because that is the key. All right, so check it out. For number 14, this is very similar to your number 14 in the homework. What we do is we set U equal to one piece. And what I did is through experience, you get better at this in terms of you don't have to guess. So I'm going to let U equal this exponent 1 minus x to the 6th. And when I do that, what I'm hoping is that somewhere in the derivative that I end up with the x to the 5th power. All right. So that's my goal. That's what I'm hoping happens. All right. So we take the derivative of this and this is what we get. And so what I did is I highlighted here, I have an x to the 5th and I have a dx. So this is actually in my original antiderivative. And that's perfect because what we're going to do is we're going to substitute some things back in. All right. So notice there is no -6 in here. So what I do is I have to move this -6 to the other side. So that's why I went ahead and I isolated this piece that I highlighted. So I moved that -6 to the other side. So now note, after I divide both sides by -6, now I have the x to the 5th and the dx by itself, right? And what does it equal? It equals this right here. And so what I did here is I just separated it so it's easier to look at and it's easier to use as we move forward here. All right, so I broke it apart. This is the same thing as -1/6 times du. All right, so now check out what's going to happen. I'm going to take this antiderivative. So let me take this antiderivative, but wherever I see x to the 5th dx, I'm going to replace that with this right here. So I'm going to replace it with -1/6. This piece right here, I'm going to highlight it and I'm going to copy it on down, right? Nothing happened to it. And then we have d. Oh, actually, I shouldn't have done that. Let me erase some parts because check this out. This right here, this exponent, I just did a substitution. So that is now u. So let me point that out to you. So this exponent, look what I did. 1 minus x to the 6th. I now said that's equal to u. So wherever I see this, I put u and now it's du. All right, so now everything here is written in terms of u because this is much easier to take the antiderivative of than this. So let me recap real fast of what just happened. So x to the 5th dx, wherever you saw that, you replaced it with this. So there's my -1/6 and there's my du. Wherever I did my substitution, 1 minus x to the 6th, right? Look what we did. We said that is u. So instead of writing all this mess, I just wrote u. All right, and now this is much easier to integrate. So check it out. So when I integrate this, I'm going to go ahead and this is a constant, so I'm going to pull it out to the front, that factor. So -1/6 is going to come to the front. So now I'm just taking the antiderivative of e to the u du, which we learned from class is itself. So what we end up with is just -1/6 e to the u plus c. And now, don't forget, we substitute whatever u was originally back into the problem. So what was u equal to? U was equal to this mess right here. So we're left with -1/6 e to the 1 minus x to the 6th and then plus c. So this right here is the antiderivative of this problem up here. All right, folks. So again, it's going to take some practice and some work. So keep your questions coming. Hopefully this helps out. Peace.